Welcome back to our Spring Security series. In the last video, we explored how Spring Security works internally, as well as introduction to Spring Security and how various components of Spring Security works, understanding its filters, authentication flow, and how requests are secured behind the scenes. Now, in this second and final theory session, we are going deeper into some key Spring Security concepts. We are going deeper to understand how some key security concepts that you will use in real-world applications work. This is the breakdown. The core classes and interfaces in Spring Security: method level security, URL-based security, controller level security, and JWT authentication. We are going to explore why we use JWT and how it works and its role in securing APIs. By the end of this video, you will have a solid understanding of these concepts, and in the next session, we will shift to hands-on coding where we implement everything step by step. I promise you that this is the last theory and PowerPoint presentation in the security session. From next video, we are going to start practical coding, practically showing all the concepts we have covered in code. So stick around, because after this, it's all about real-world implementation. Let us get started. So in this video, we are going to look at some key components and methods involved in Spring Security. Key components and methods involved in Spring Security. So we have authentication object. Basically, an authentication object represents the user's credentials and authentication status. An example of authentication object is username password authentication token. What are the key attributes of authentication object? We have the principal, which is the user's identity. We have the credentials, such as password. We have authorities, roles or permission, and we have a flag called authenticated. This is a Boolean flag indicating if the user is authenticated or not. The second key component is authenticated method. We have a method called authenticated, defined in the Authentication Manager interface. It takes an authentication object as input, returns a fully populated authenticated object if successful. Security context. Security context. What is a security context? A container that holds the authenticated user authentication object. Basically, this is a container that holds authenticated user authentication object. It is updated via the following method. So you call this method to update the security context. Security context holder dot get context dot set authentication. Security context holder dot get context dot set authentication object. In this case, we are going to see how things are implemented practically. This is accessible globally to determine the current user's authentication status and roles. Then we have password encoding. Remember, we don't store password as raw text. It is a bad practice. We store password as encrypted or hashed. So passwords are encoded for security purposes using implementations like bcrypt password encoder. The matches method compares raw password with encoded one. Let us now look at some inbuilt classes or interfaces for authorization. We have granted authority interface. We are going to interact with granted authority so much in the course of our coding session. So what is granted authority? Granted authority represent a permission or a right assigned to a user. Permission or a right assigned to a user. Think of it as the user's access level in the system. It tells Spring Security what actions the user is allowed to perform. For example, role like role admin or role underscore user are often represented as granted authority. If you have a driver's license, it grants you the authority to drive. Similarly, a granted authority grants a user specific access or permission. We have simple granted authority. Simple granted authority is a simple implementation of the granted authority interface. So basically, this is the implementation of granted authority interface, and it is provided by Spring Security. It stores a single string like a role to represent the authority. It is an easy way to represent and use roles or permission in a Spring Security-based application. Instead of creating complex classes, you can directly use this. So all these things, we are going to see them practically in a short while. Now, let us go to techniques to implement authorization or managing access. Remember, we are not just handling authentication, but we are handling both authentication and authorization. So, we have various ways of various techniques to implement authorization. I'm going to discuss various ones like method level security. So Spring Security allows restricting access to methods using annotations like at pre-authorized, at post-authorized, and at secure. So basically, method level security allows controlling access to specific method based on user roles or permissions. So basically, for you to use the method level security, you have to go to security config and write an annotation at enable method security. Inside your security config, you have to enable method security. So an example of method level authorization we have at pre-authorize. These annotations are very important because we are going to use them. Pre-authorize, execute before a method call. Basically, this checks condition before calling the method. So this is the structure at pre-authorized into bracket has role admin. This basically means that only admin can access this method. We have at secured specified allowed roles for the method. It specifies the allowed roles for the method. Example, this is the syntax. At secured into bracket role user, role admin. So here you pass a list of roles that can access this method. Only role user or role admin can access this method. The other one is at role allowed. At role allowed. Role allowed. You pass a list of role allowed. So admin and manager can access this method. Okay. Then we have at post authorize. At post authorize, it is used to enforce security after a method has executed. It evaluates conditions based on the method returns value or the current security context. So at post authorize, returns object return object.username is equals to authentication.name. So basically, this one allow access only if the returned user's username matches the logged in username. So you are checking whether the returned username matches the logged in username. So basically, that is method level security. And if you want to apply, there is another way of applying or managing access called URL based security. you can define security rules for specific URLs in your security filter chain configuration. So basically, we are going to see this practically. The other one is controller level security, where you can secure an entire controller instead of securing individual methods. So basically, for controller level security, we use annotation at pre-authorized. Pre-authorized. Now, that is it for managing access. And this approach provides fine-grained access control while keeping the code clean and maintainable. Now, the other thing that I want us to look is JWT. JWT, JSON Web Token. JSON Web Token. So these are very important concept in Spring Security, and we are going to implement JWT based authentication in our upcoming videos. So I want to define what is a JWT in a very basic language, in a non-technical terms, because I want you to understand this concept very well. So imagine you are entering a high security building. At the entrance, a security guard checks your ID, verifies who you are, and gives you a special entry badge. This badge allows you to access certain areas of the building without needing to show your ID again. Now, think of JSON Web Token as a digital version of this badge in the online world. When you log into an application, the system verifies your identity and gives you a JWT token. You can then use this token to access different parts of the system without logging in again, as long as your token is valid. So basically, what problem does JWT solve? Before JWT, system often used session-based authentication, where user details were stored on the server. This caused some problems such as scalability issue. Scalability in this sense, the server had to store session for all users. Assuming we have 50 million users, you have to store 50 million sessions. Performance overhead. Every request had to check the database for the user's session. So imagine after every request, you check the database for the user session. So this was very tough, and it brought a lot of performance overhead and bottleneck. JWT solved this by removing the need for server-side session storage. Instead, the user carries their authentication information in a secure token that can be verified without a database lookup. So JWT basically is a compact and secure way to transmit information between two parties, e.g. client and server, as JSON object. It is often used for authentication and authorization in web applications. Now, I want us to look at the structure of a JWT. A JWT has three parts separated by dots: header, payload, and signature. Header, payload, and signature. Let us look at these things. What is a header? It contains metadata about the token. The header contains metadata about the token. Example is, this is an example header. It contains the algorithm used for signing, e.g. HMAC, SHA-256. It also contains the type, which is the token type, the JWT. So this is an example of header where where the information or the metadata is the algorithm and the JWT token type or token type. So, and this is an encoded version. These are base 64 URL encoding for JSON above. Now, let us go to the second part, which is a payload. A payload contains the data or claims, e.g. user details or permission. Example is sub, which is subject, basically the user ID, the name, which can be username, the role, which can be user role, IAT, issued at time, EXP, which is expiration time. So, best practice, do not include sensitive information like password in your JWT payload. Do not include sensitive information such as password in your JWT payload. Okay? Then let us go to signature. What it is. Signature ensures the token has not been tampered with. It ensures that the token has not been tampered with. I want to give you a very good example. Think of a signature as this. Think of it as a private stamp used by a company to validate document. If a document has this stamp, you know it's official and has not been forged. In JWT authentication, the signature or the secret key is used to sign the token so that when the server receives it, it can verify that the token is legitimate and hasn't been altered. So this is how the signature is generated. You specify the algorithm. So this one will be a base64 URL encoded. You pass the header, you pass the payload. So it verifies the token authenticity using a secret key or private or public key. Basically, what is a public? What is a secret key? A secret key is used to sign the token so that when the server receives it, it can verify that the token is legitimate or it has not been interfered with. And basically, there are several types of secret key or signing algorithm. Basically, there are several types of security key. So we have private and public. Now, what are some of the security considerations for secret key? Number one, security is keep it private. If someone gets access to the secret key, they can forge valid JWTs. The other one is use a strong key. A weak secret can be guessed. Use a strong key. The other one is it is good to rotate the keys periodically, changing the key over time to reduce the risk of exposure. And also use environment variables to store key. Never hard code the secret key in your application code. So basically, I wanted to show you an example of JWT token, but we are coming back there. So let us explore how JWT works internally. This is high level. So when a client logs in by providing username and password, the server creates a JWT token. The first step is client logging in using the credentials, username and password. Then the next step is creation of JWT token. If the credentials are valid, header specifies sign-in algorithm, e.g. HS256. The payload contains user data. Signature ensures integrity, created using the header, payload, and secret key. Token sent to client. The server sends the token to the client, usually in the response body or a cookie. The client uses this token with every request. For every protected API request, the client includes the JWT in the authorization header. So you have authorization, you pass it in this format: authorization, bearer, then the JWT token. Server verifies the JWT. The server decodes the JWT, validate the signature using the secret key, check the token's expiration time, access granted or denied. If valid, the server processes the request. If invalid, tampered with, or expired, access is denied. So in short, we can summarize this by saying that once a user logs into the system with the correct username and password, the server generates a JWT token. After generating the JWT token, it sends that token back to the client. So once the client receives that JWT token, it sends that token together with the request to the server. The server extracts the JWT token, verifies if the token is valid, and then process the request. Implementation steps. How do we implement JWT token? The first is to create the very first thing is to get the JWT dependencies. So you get the JWT dependencies and put them in the pom.xml file. Then you create a JWT utils. What is the purpose of JWT utils? A utility class to handle common JWT related tasks such as generating JWT, it creates a token after a user logs in, validate JWT, checks if token is valid, that is not expired, not tampered with, it extracts data, like retrieves user information like username from the token. The other thing that you implement is auth token filter. Auth token filter. A filter that processes incoming HTTP requests. So what are the responsibility of auth token filter? This is a very important filter. It intercepts request. Check every request for a JWT in the authorization header. So this is a filter that for every request it checks for a JWT in the authorization header. Then it validates JWT, ensures the token is valid using the JWT util. It calls the methods in the JWT utils to validate the token. Set user context. If valid, it adds user details, username, roles to the security context. So Spring Security know who is making the request. So we also have authentication entry point JWT. Handles unauthorized access attempt. So what are its responsibility? Detect unauthorized request. Triggered when a user tries to access a protected API without a valid credentials or token. Send error response. Returns an HTTP 401 unauthorized response with message like access denied or invalid token. Then we also have the security config. Configure security settings for your application. So what are some of the responsibility of the security config? So this security config should be annotated with at configuration and at enable web security. So these are the responsibility of Spring Config. It enables JWT authentication, sets up auth token filter. Remember, we have talked about auth token filter. So we set this filter in the Spring Security config. Links authentication entry point JWT to handle authentication errors. It defines API access rule. Specifies which endpoints need authentication and which are public. We are going to see all this information just in a second when we start the actual implementation. So that is the end of our PowerPoint presentation. In the next video, we are going to start doing things practically. So be prepared. Thank you.